So apologies in advance if so actually two things. First off, apologies in advance. I am, as you could possibly tell, un-American. And yeah, it's been a rough few years for everyone. Second, I did just fly in yesterday morning, so I'm still getting a little bit used to the time zone difference, and it's been an exciting 24 hours, let me tell you. So I hope you're here to hear about cloud-native observability with OpenTelemetry, as it says in the slide. First, real quick question to kind of level set. Who here is using OpenTelemetry today? So about half, cool. For that half, like production, all right, rad. And let me just turn on Do Not Disturb so pop-ups don't happen, great. So for the other half of you, well, for both groups of you, this is a pretty, I won't say like overview talk, but I'm going to go through a lot of different parts of OpenTelemetry. Some of this may be very applicable to you, some of it might not be applicable to you. We will leave room at the end for questions. So also, if people at the doors want to try to tuck in a little bit, there is a crowd forming behind you. And last little quick piece of business. After the talk, please come up and get your commemorative OpenTelemetry Pride sticker. So let's quickly go through what we're going to be talking about. First, a little bit on observability, just to kind of make sure we're all speaking the same language here, metaphorically at least. Then we'll talk about OpenTelemetry deployments, getting started with it, and then finally I'm going to show you a little demo of OpenTelemetry in Go with the OpenTelemetry demo application, and then finally we will have Q&A. So first, let's talk about observability, why it's important, and why it's especially important for cloud-native developers. First, we should tell you who I am and why I am here talking to you in the first place. So I'm a maintainer on the OpenTelemetry project. If you aren't familiar with OpenTelemetry, it is a merger of OpenTracing and OpenCensus. It is managed by the Cloud Native Computing Foundation, who you might know as the people that do Kubernetes and other fun things like that. I have written a book about this called Distributed Tracing in Practice, available on O'Reilly, and I run the Developer Relations program at Lightstep. Also, you might also know me as the guy that ran the Animal Crossing DevOps conference. We will come back to that at the end. So, why is the cloud native part of this important? Well, the cloud native part of this is important because many, many people, especially people in this room probably, if you're not using Kubernetes, then you're going to be soon enough, right? It's inevitable at this point. Kubernetes has won sort of the container orchestration wars, and we have decided as an industry that container orchestration is a great way to handle a lot of boring crap that we really don't care about and we want someone else to do for us, like restarting things when they stop. And that's cool, but there's a downside to it. As we have better and better tools to create cool distributed systems, we have this understandability problem, right? If you think about one of my favorite analogies for this is trying to run any kind of system is like trying to lift a really big rock. And if you have a boulder, if I had a boulder over here the size of, half of this room, and I try to go over here and I try to roll it across the stage, I'm just like, da-da-da-da. That's really heavy. I couldn't do it myself. The way I can actually accomplish this is I can use some kind of tool, right? I can use a lever. I can use a lever and then get some friends, and then we can all push on the lever, and that will multiply our force against the boulder. Similarly, observability is that lever for systems understanding and knowledge. It lets us help model our systems. It helps us understand our systems. When something goes wrong, we're not isolated just looking at like one little point and being like, okay, well, there was a stack trace, there was an exception, there was like an out of memory or some sort of resource exhaustion. It lets us understand those failures in the context of everything else going on. And that's important because with cloud native systems, the everything else going on gets bigger and bigger and bigger and bigger and bigger. And now our systems are mostly things that we don't control or run or even understand. So we need that kind of observability about what's going on in order to do a lot of like software things, right? We want to ship our software faster. We want there to be less bugs in it. And we want it to really focus on how our end users experience software. It's one thing to sit back and say like, well, we want no bugs, right? Or we want 0 incidents, but that's never going to happen. There's always things that will happen that are outside of your control especially the cloud, but really in any kind of system at all. If you work for, who works for a place that's multinational, right? You have dev teams in the UK, in the US, in India, wherever, right? How many of those dev teams that are on the complete opposite side of the world, how many of them have services that interact with like the code that you're deploying? They can change things you'll never know about. And when those changes cause things to break and they cause degradation of end user experience, that's really the only thing you can monitor and measure that is worth your time. Because sure, you can just like have all these like really cool unit tests, you can have all this sort of data about like how great our thing is, but if it's not being put in the context of how does this actually make our customers happy or sad, then you're kind of wasting your time because those customers are the only ones that actually really end up mattering. Observability helps fix this because it puts everything in kind of that context of systems understanding and systems knowledge. Now to have observability, you need these three things. You need high quality telemetry data, high quality context-aware observability tools, and then practices to help you kind of operationalize that data using those tools. OpenTelemetry fulfills this first one, right? It is our telemetry data source, our telemetry framework. The original goal of the project that we put on the webpage, at least, was to make OpenTelemetry enables effective observability by making high-quality, portable telemetry ubiquitous. So we want high-quality telemetry, like metrics, logs, traces, signals from your application about what it does. We want those to be of a uniform quality, and for that quality to be very high, so we want that data to be useful, and we want to make it portable. So we don't want you to be in this kind of very classic trap of my company uses New Relic, so we have to use the New Relic agent, and we can't use the New Relic agent because the New Relic agent charges us per hosts, and we stood up this new thing, and we can't afford it. Or we're using Datadog, and we really could use this custom metric, but adding a custom metric costs $1 billion, and we're very locked into these sort of systems, right, where everything is very transactional, it's compartmentalized, it's based on how much can we pay to a monitoring vendor rather than what do we actually need our applications to tell us in order to make sense of our systems. By moving all of that telemetry gathering process, all that telemetry definition process out of proprietary vendor-based agents and libraries and pulling it into the open source community, we can do two things. One is that we as developers are very free to just use this now. It's open source, it's on GitHub, hooray, problem solved, right? But two, the tools we use and the frameworks and the libraries and all the bits and bobs about our systems that like we leverage in order to do our work faster, things like Kubernetes or microservice frameworks or what have you, they can integrate OpenTelemetry. And then I don't have to go in and write a bunch of like tracing code for every single thing I write. It's just there, right? I know this is a Go conference, but if you look at what like Rust or .NET or Erlang have done with OpenTelemetry, they've integrated into like effectively framework level, language level tracing and metrics and logging libraries. So it's just there. It's like air. You don't have to think about it. Whenever you set up an HTTP server, you have tracing. Boom, done, right? Eventually, we would love to get to that place with Go. So OpenTelemetry is, kind of as you intuited from this, it's not really a way to like build these telemetry sources. It's really almost more of a way to build things to help you build that telemetry, right? Really the point of integration is designed almost to be at a little lower level than kind of, average end user developer. We really designed it to be built into the language or built into other frameworks that you're using. And that's why it's designed the way it is, right? It has APIs, it has SDKs, and it has this really cool tool chain to help enable that. So one other question I get a lot is, why did you all start with traces? Anyone here a fan of logs? Woo! 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 Okay. But this is something I get pretty often in like the OpenTelemetry Slack, which is like, people will come in and they'll be like, I have all these logs, and I need to get all these logs, and I need to get all these logs, and I need to put them somewhere, and that's how I understand what's going on, is through my logging framework. And OpenTelemetry says, actually, you should be using traces. And, that's a curious thing to folks that aren't really used to traces. to review very briefly, a trace is a context-aware distributed logging statement. And it has a schema, so it has all the, things like a context ID, right? It has a set of attributes. It has a parent-child relationship defined in that schema. And it's also very important, traces can be represented as metrics through aggregation. The key thing about a trace is the distributed context-aware part of it. I can have a trace that starts at my iOS client or my web client or whatever, and goes all the way through my plethora of Go microservices all the way down to some Postgres DB, and every single unique transaction will be linked together with a globally unique trace ID that I can then go and look at and see, like, okay, what happened for session ID blah. Regardless of where I am in what part of that I own, right? Maybe I own a couple of Go services down here. I can pull the ticket from Jira that has the session ID from the front end, look at that trace and be like, oh, okay, well this was my problem or it's not my problem, right? But again, it's a context-aware distributed logging statement. And that's why OpenTelemetry is kind of trace first, because traces are just logs that are put together in a way that makes sense. If you have a service like this, some API that is going through authentication, payments, everything, trying to actually map this out and model this can be really challenging with just logging statements that just have basic correlation IDs, especially if you don't share the same schema for how those log statements are printed out across every single one of these services, across every language that it might be in, right? Each unit of work in this system is, in a trace, is called a span. And those spans are generally displayed as kind of this reverse flame graph or waterfall graph that if you've used something like Jaeger or any kind of APM tool, you're probably familiar with a view like this. Every span has metadata. The metadata are attributes and events. Attributes are key value pairs. Events are key value pairs that can also have kind of human readable messages. So you can almost think of them as logging statements inside the span. The point of trace first as part of telemetry is that all those other signals that OpenTelemetry is concerned with, like logs and metrics, they can all be linked back to traces. And they can be linked to traces through this distributed context that OpenTelemetry ships with. So the real reason that OpenTelemetry does traces first is because we need to put that distributed context everywhere so that we can then go back and correlate your metrics and your logs. In a kind of perfect world, your application itself, all of the things that you would log traditionally as part of a single request from your app would be represented as a trace. And then things that happen kind of outside of that request lifecycle, that would be a logging statement, right? So I've got traces for anything that can be associated to like a unique user session or a unique request, and then my init, my shutdown, my crashes that happen outside of a user request context, that would be your logs. And then there would be a way, because that distributed context is there, even if that crash happens or that out of band kind of logging statement gets printed, it could still be associated with maybe the last request that went through due to the context being held in memory. The other really good thing about traces is that they can be turned into other sorts of data. I mentioned that you can take traces, you can aggregate them, and you can turn them into metrics. I'll show you this later, but I think that's a really important thing to keep in mind because traces let you effectively get end-user facing, rate, error, duration. They get you the golden signals just by default. Every single span in a trace knows how long it took because that's what the spec defines, right? It knows if it completed successfully or not. So there's your errors. And then rate is just it's doing a rate across however many traces you saw. Because of that, it's a really good data source for things like service level objectives, but also things like service graphs, right? So I can see how are all my different services correlated together based on that explicit relationship defined in the trace itself. OpenTelemetry is built and designed really to help standardize this throughout the cloud-native ecosystem. So there's these four kind of basic things. First, I kind of touched on this already, is that it is open source, it is cloud-native, it is part of the CNCF. It's being integrated into Kubernetes, it's being integrated into many other frameworks and libraries. I mentioned like C#.NET, Rust, Erlang, but because it's something that can be integrated pretty easily, you're starting to see it pop up in more and more, like Go frameworks or, JavaScript tools, things like that. The second big part is this idea of semantic conventions. So one challenge with telemetry in general is that if you are in a polyglot environment, then how do I make sure that every single service that is emitting telemetry is going to represent the same metadata in the same way? Because if I want to do sort of a comparison across different clouds or across different services, then I need to make sure that like an IP address has the same key, or a user ID has the same key, or like a Kubernetes node or some cloud component. These all need to have standards for how they're represented. OpenTelemetry provides that standards through the OpenTelemetry semantic conventions, which means that my node service and my Go service and my C# service and all these different, my Java service, are all going to say, like when they emit a trace or a metric or a log, that the host name of where that was being run is going to be represented the same way every time, which means it's much easier to do queries where you're looking for, like, hey, aggregate this or group this by host name, right? The third thing that's really important is OTLP. OTLP stands for OpenTelemetry Protocol. It is a vendor-neutral wire format for expressing metric, log, and trace data. And it's truly vendor-agnostic. If you want to receive OTLP as a vendor, you simply need to implement a gRPC endpoint or a JSON over HTTP. Just accept this data format and translate it to whatever you want. If you want to send it, kind of the inverse. You just need to import the appropriate libraries and then write a wrapper around what you have and turn it into OTLP. If you, as a developer, your company adopts OpenTelemetry and you use OTLP, then you're not only future-proofing, you're present-proofing yourself, because a lot of people use this today, but also you're future-proofing yourself because maybe you do say, like, oh, well, we're going to use this with like our home-brewed Jaeger plus Prometheus plus whatever. We have our own internal thing that we're using, and it's great. Everyone likes it. It works pretty well. You send it OTLP. Cool. A year passes, 2 years pass, and suddenly you're growing or your needs change, and you start to look at SaaS solutions, or you start to look at other hosted solutions, or maybe there's some cool new observability thing that comes out open source that you want to try. OTLP means changing between those two backend systems for analysis is literally just change the endpoint it's going to. So no more re-instrumenting your software, which is handy. Finally, there's trace context. So this is W3C, and the default in OpenTelemetry is to use W3C trace context to actually propagate that distributed context I talked about. There's a few cool wrinkles to that. One, since it's a W3C standard, that means that things that are kind of lower from the application layer can understand it. So eventually we'll see that at sort of the networking level, where you could have routers and things that are aware of traces, which would be neat. And knock on wood, this means that other libraries and frameworks will stop accidentally eating trace headers when they're passed through them, because this has been, if you've been using tracing for a while, then perhaps you're familiar with traces just getting kind of silently broken by systems that don't propagate the headers to further requests. So standards, they're cool. OpenTelemetry itself in a deployment, how it works at a high level, is you have two parts. You have your transaction and your resource telemetry. Transaction telemetry is going to be that stuff I mentioned before. It's the application level stuff. It's things that can be associated to like a unique user session through your application, and that's your traces, metrics, and logs. And then you have resource telemetry, which is kind of anything that isn't that. So your database metrics, your VM logs, your Kubernetes, traces, things that can't really be associated to a unique customer or end user transaction would be the resource telemetry. All of that stuff goes to a collector, or a group of collectors usually. The collector is a Swiss Army knife, effectively. It lets you take in telemetry from a bunch of different formats, do stuff to it, like redact it or change it in a different format, and then send it on somewhere else. The OpenTelemetry sort of native way to do this is to, again, export OTLP and then send it to open source tools like Jaeger and Prometheus, or to one of the many vendors that either has their own custom collector, exporter, or accepts OTLP itself. There's I don't want to like go into this like too much, but if anyone is interested in like what does this look like to migrate kind of like from an in-house thing to OpenTelemetry, Shopify did a really good talk at KubeCon EU a couple years ago. You'll be able to find this link in hopefully the notes somewhere, or find me afterwards and I'll tell you how to look it up. But they did a really cool talk where they went through like how we transitioned from like our in-house stuff to OpenTelemetry, right? And it was actually fairly straightforward. They took a custom receiver, put it into the collector, and then started kind of shifting traffic over. And they were able to do all this without code changes because they were able to kind of put the effort of actually converting the data from the old format into OTLP in the collector itself and not in their code. And now, once they switched everything over, then it's like, okay, as we go back to these old services and we start to, as cleanup tasks, we can go and we can re-instrument those, but we don't have to. We can use the collector to kind of make sure that all the output is the same format. So how do you actually use this? How do you get started with it? Well, it's fairly straightforward. There's two parts. You need to instrument your code, and then you need to collect and export that data somehow. Instrumentation is, the experience differs based on your language, let's say. So as Go developers, you are probably, hopefully, pretty familiar with boilerplate code. And boy, right now in OpenTelemetry, there's quite a bit of that. For other languages, it is a little more straightforward. There are automatic instrumentation agents right now in like Java and C#, Node.js, and Python. You can use extensions. So if you're using like AWS Lambda layers or AWS Lambda, there are extensions you can plug in as Lambda layers to automatically instrument those Lambdas for you. Or if you're in Kubernetes, there are operators that let you do the same. And then for Go, Ruby, and other languages, you have to integrate it at a library level. I'll show you that. This is the Java one. With Kubernetes, you're creating a custom instrumentation, a CRD, using the OpenTelemetry operator, and standing up collectors, and then annotating pods where you want to inject the automatic instrumentation. Tell your DevOps friends, your SRE friends about this. They might find it cool. For Go, again, a little more boilerplate. You need to put in a bunch of dependencies. So everything is in the go.opentelemetry.io namespace. And then you need to initialize tracing and export. And this is kind of the bare minimum. There's two ways to do this. I'll show you when we go into code in a minute. I actually highly recommend not doing it this way. You want to usually keep all of your instrumentation code and your init separate from your actual app code. So you want to write some sort of module, like a tracing module that handles this stuff for you, that sets up export, that sets up all the behind the scenes stuff, especially when you're adding OpenTelemetry metrics, because there's a lot of initialization code there too. But keeping that in a separate module that you can kind of control is very handy, and often cuts some of the stuff that I'll show you that's like a 3-liner. If you write a few little helpers, it'll cut it down to a 1-liner. There is maybe a little help on the way though, and at Lightstep we came up with this thing called an OpenTelemetry launcher, which is basically simplifies a lot of this init stuff. So like, instead of having to do all this, you can just kind of do this nice Fluent API. Us and our friends at Honeycomb are trying to actually get this into upstream, and we're trying to work on a lot of sort of developer experience niceties for OpenTelemetry right now. So if you're active OpenTelemetry users and you find the API frustrating or difficult to use or any of that stuff, then and you also kind of want to get involved, then this is a good place to do it by kind of advocating for better developer experience around like initializing OpenTelemetry, using OpenTelemetry. But hopefully we'll see something like this in the near future. Either way, once you've initialized OTel, then it's a little bit of a choose your own adventure. Generally, you're going to want to add some sort of wrapper around whatever your RPC library is. So if you're using gRPC, then you need to import the gRPC instrumentation libraries for OpenTelemetry, and then you need to add stream interceptors. And once you've done that, the cool part is OpenTelemetry will just kick in and start to create new spans. Every time a gRPC request comes in, it will look in the headers. It will say, is this already part of a trace? It is. Cool. It will pull that trace ID, pull that trace context out of the headers. It will create a new span as a child of the existing span. And then when your request completes, it will end that span, send it out. You can also grab those spans, which is very cool. One thing to note here is, and this is obviously best practice in general in Go, but you really got to make sure if you're using tracing that you are passing context.context all the way down wherever you want traces to go. Because if that context object drops, then your span, you no longer have access to the span, right? But if you do have context, then you go into a function that's called from like your gRPC handler, and you can say, hey, give me the actual span that's being created right now, and then let me add stuff to it, right? So I can, in this case, we're listing all of our products, and then returning those over gRPC. I say trace that span from context, and then set attributes and put something that's actually like a interesting business thing, right? OpenTelemetry gives you a lot of these conventional resource-based attributes. So, like I said, host name, Kubernetes node, whatever. But the stuff that makes us very useful is the things that actually matter to your code. So, sort of more business attributes. Think about it this way. If I'm having an outage, I want to be able to say, like, okay, for all of this stuff, which parts of these are on the impacted server or on the impacted node? Cool. Semantic attributes help you with that. But the real question isn't just what node are they on, it's also what is the cross product of customers being impacted by this and the nodes they're on. And having things like app.user.id or app.session.id or whatever, having those kind of custom attributes added into your instrumentation is where you start to really see a lot of value out of tracing and being able to ask those kind of questions. The OpenTelemetry API lets you do a lot more than just that. You can do sampling, you can do events, you can do quite a bit of other things, and it's also very composable, so you can kind of add new stuff in. The OpenTelemetry documentation on the OpenTelemetry.io website is a good resource for it, or just looking at example code. So you've got instrumentation, you've got traces, you've got all this stuff being exported. Great, what do you do with them? So generally we recommend using the OpenTelemetry collector. And the reason why is because you don't have to. You can just send data straight from your service to something, right? To Lightstep, to New Relic, to Jaeger, whatevs. Putting stuff through the collector gives you a few, beneficial things. The biggest is this processors. So you can do stuff like you can filter out spans for health checks. Maybe you don't care about health checks because they're not interesting to see a span for. So you could filter those out through your instrumentation in your service, or you can drop them at the collector because it's easier. You can also hydrate traces more, so you can do stuff like the collector can, for example, tag spans based off of like Kubernetes resources, or like what node this is running on, what the pod name is. And it also, of course, lets you receive and then export to a bunch of different formats. Installing the collector, again, this isn't, you download it. The one thing, if you're trying to play around with this on your own, because I see this catch people, is there's three things. One, the releases of the collector are actually in a different repository than the collector code. So it's OpenTelemetry-collector-releases. And then there's two options there. There's the core and then contrib. You usually want to get contrib if you're kind of playing around with this, because contrib has all of the receivers, exporters, processors. It's got all the extra stuff in it. And if you're doing this in production, you usually want to use the OTel collector builder to create a custom binary that reduces the size and complexity of the collector image. The collector builder is, you hand it a collector manifest, you hand it a YAML file that has all the stuff you want, and then it will spit back a custom Go binary for you that only has that stuff built into it. You can even pass it Go modules directly if you have like a custom processor that your company wrote or that you wrote and you want to build that in. You can just tell the collector builder, hey, here's where this lives. It'll pull in that module and build the whole thing. So the collector is completely written in Go as well. So the collector is based around, configuring the collector is based around this idea of pipelines. So you have receivers that flow to processors that flow to exporters. It's like all good cloud native projects, completely configured in YAML. But you can see a sample of the configuration here, right? You define your receivers, you can also do cool stuff like you can throw in Prometheus configs directly into the collector if you want. Here pretty soon, I don't know the exact date, but there's going to be like a drop-in replacement for Prometheus and Kubernetes with the OTel collector, so you don't have to have Prometheus plus the OTel collector if you're sending the metrics somewhere else. You specify a processor, you specify various levels of exporters, and then once you got all that at the top, you say service section, pipelines, traces, metrics. You can have multiples of these, so you can have traces go to different places at the same time. We see a lot of people do this at Lightstep when they're trying us out. They will just duplicate their config and then send the data to the current place and also to Lightstep. You can also do stuff like if you only wanted to send like 10% of the data to a new place, right? You could create a sampler that would do that filtering for you. And since Lightstep supports OTLP natively, actually sending us the data is, again, just you configure an OTLP exporter and you send it, you give your access token. It's cool. So let's actually switch over to something that's a little more concrete, right? Like, well, how is like, I just told you a bunch of junk about like exporters and processors and instrumentation, but what does this actually look like in practice to have a system instrument with OpenTelemetry, and how is that useful for you as a developer? So imagine we have some e-commerce site. And what do you do with an e-commerce site? Well, you have a shopping cart, you buy stuff, you place orders, you send out emails. There's a lot of like discrete kind of end user journeys and flows in that site, you know, and those journeys aren't necessarily, you know, super linear, or at least maybe they don't get mapped out one-to-one. If I think about like when I go and I say, if I go on Amazon and I put a bunch of stuff in my cart and I hit order, you know, what happens for me? Well, it spins for a minute, and then I lose some money, and then I get an email, and then some days later, some stuff shows up at my door. But a lot of different, you know, components happened working mostly independently of each other for that result to occur. So, and if any one of those like individual components breaks or there's a problem with it, then that makes me sad as like the customer, and it also probably makes the person that is developing that e-commerce site really sad because they have to figure out like why it broke. So this is a diagram, kind of a logical diagram of a sample e-commerce site, right? And I can see that I have a bunch of connections here between things. I have a feature flag service, and then there are things that are, you know, calling that feature flag service and asking for flags to be evaluated. I've got a front end that talks to a recommendation service, to a product catalog. I have other lines that should be drawn in here that are not. But we can actually go and look at this, you know, like slides are great, but what we really love is live demos because these always go super well. So this is the OpenTelemetry demo application, and it's actually in the middle of being the front end of this is in the middle of being rewritten. So it's a combination of eventually it's going to only sell telescopes, but right now it also sells sunglasses. So as you can see, I'm going here and I'm adding things to the cart, and you might notice that there's a couple of like weird little things, you know, cropping up through here. It's a little slow sometimes. Some images aren't loading. Why is that? Well, that's a great question. How would we normally figure this out? Well, normally the way that I would know that my site was broken is that I would go and I would get paged, or I would get a message in Slack or get text or whatever, and it's like, this particular endpoint has an elevated error rate, right? It crossed some threshold. Now, the actual error, those errors probably started occurring like 10, 15, 20 minutes ago, right? Like, there's usually a pretty big delay between when problems start occurring and when you actually finally get a page saying, hey, the problem is occurring, because of, it takes a while for all of the things to go up. Unless everything is just down. But if everything is just down, that's really easy. You just turn it all off and back on again, right? So, but meanwhile, I'm the customer. I'm just like, why can't I order my sunglasses? So you would get paged. You would go and you would see that this particular API endpoint or something is suffering like an elevated error rate. And that would kind of be it. You would be, all right, well, I guess I gotta go, maybe if you're lucky, that's narrowed down to like one service, right? The service that you're responsible for. So you're like, oh, I know my service is seeing something on this. So time to pivot over and time to start looking at logs and dig through all these logs and start grepping around, or going into OpenSearch or Splunk or whatever, and trying to find like what information do I have from my metrics, which might be not a lot, right? Like, depending on how scaled out you are, and because there's this whole thing of like high cardinality metrics, right? You can't have too many unique attributes. You can't have too much data on those metrics. Otherwise, they get really expensive and really hard to search through. So you might have a pretty broad idea, like I know that it's this service, and I think it's this data center, or it's this component, or it's this thing. And then you go into your logs, and you look, and you look, and you look, and you look. Well, with tracing, I'm able to ask better questions. So I'm able to say, like, this is Jaeger. If you're not familiar with it, this is an open source trace visualizer, trace analysis tool. So I can start out by saying, all right, well, I know there's a problem with the product catalog because it's my service, and maybe I even saw like there was an error trying to get products. So I can use Jaeger to say, like, show me all of the operations or show me every invocation of that operation that happened in some time window. And I can actually start to see, like, okay, there's a couple of interesting things here. I'm getting my rate error duration stuff, right? I see, like, here's stuff that took a while. I see these red dots, these are errors. And I can jump in and I can look and be like, all right, what was the exact problem in this particular thing? And I can see that I made the problem happen with the feature flags. But again, I'm able to jump down and like see that exact problem, see that like really micro scale. And that's cool. And I think this is where a lot of people this is like maybe the aha. This is maybe the aha moment for a lot of people with tracing, is that ability to like really narrow down and see just like, oh, I can see this pinpoint. I can find the needle in the haystack. Where I think, and for a lot of people that's cool, that's what they want, right? But I think where tracing becomes like actually really cool is when you pull back and you start to go and think about, how do I look at traces in aggregate? So this is not meant to be a light step pitch, so please don't take it as one. This is actually what I'm hoping, like, I think this is stuff that you can do with OpenTelemetry, I should say, right? Like, OpenTelemetry has processors that let you go in and build out like features like what I'm going to show you. It just takes a lot of work, and that's why you would pay someone to do it. But these sort of aggregate trace analysis concepts are where tracing becomes extremely worthwhile. So I'm going to go into Lightstep, and I'm going to open up a notebook that I've created that is looking at traces from all of these different requests. So there's not just the requests I'm making, but I have a load generator going, so it's constantly going through and it's hitting various endpoints here. So I'm able to go and actually look at all the requests that are happening and say, like, okay, well, let's maybe do some interesting queries. So I know that there was a product that was having a problem, because that's where I made the problem. So I can go and I can create a query that's like, hey, group all these by product ID. And this is an attribute that I created in Go. So if I get rid of undefined, that's a weird one. I can sort and see that this particular product ID is the only one that really has like anything interesting here, and if I go and I look at the heat map, I can actually jump in and go to a exemplary trace from that that was for that product, which, as we can see here, is the sunglasses where the image didn't load, right? Ta-da! It's very easy to make a really cool demo when you know how it's going to break. But that's something that actually was kind of like, that's kind of hard to do in just a trace visualizer, right? Because you have to know a little bit of what you're looking for in something like Jaeger to go ask these questions, whereas something that is able to kind of step back and look at everything is, everything all at once at least, lets you kind of have these more interesting sustained queries. So, that's that. What about like a more normal sort of thing, right? Like just looking at every non-200 response. So across across every single thing, I'm able to really quickly, visually look at this heat map and say, like, well, yeah, most of my stuff is down here. Most non-responses are very fast, but I can see that there's some stuff up here. And what's interesting is I can look and see that these green dots are things where there's no error. The red dots are ones that have an error. This can inform me of all sorts of things. One, perhaps I'm having timeouts, right, that aren't considered errors, but that's maybe bad customer experience. The other kind of intuitive one is that the errors are actually happening very quickly, which is actually probably good, because if you're going to fail fast, right? I can also do like analytics with this even. I can say like, well, how many people, how many products are in someone's basket when they check out? It's not just like, was it a 200 or a 400 or kind of, technical things. I can start to ask interesting questions about like, what is performance like for people relative to like, what are they actually doing versus, some other function of the software. And because traces have effectively infinite cardinality, as long as you have a database that can support it, I can do a query like, for like my checkout service, group that by user ID. And the way this works, the load generator works, is every single session is a unique user. So as you can see, I have a lot of individual user sessions, and I'm able to look at any single one of those, a lot of user sessions. And I'm able to actually group this by that, something with a one-to-one cardinality, and kind of go in and look at any one of those sessions and see like, well, what was performance like for that person, right? So again, cool stuff you can do with tracing and aggregate analysis versus just looking at like one individual trace. To talk a little bit about just like how is this implemented, so you can actually find all this yourself if you go to open-telemetry /OpenTelemetry demo on GitHub. Then this application is, right now it's in pretty active development. We're trying to get it to like 1.0 or more buttoned up by September or something. But as you can see, the bulk of it works. So here is, well, some about initializing. This is really small for you all, probably. Is that better? People in the back see? All right. So if you do have sufficiently small services and you don't want to like factor out your tracing initialization into another file or module, then you should at least kind of keep it in its own separate function. This is basically the least amount of code possible to write to do this. In addition to, this is using gRPC. If you can't use gRPC for whatever reason, there is a JSON version of OTLP, so JSON over HTTP. And the minimum you kind of need is to tell it batch or don't batch, right? You should always, for really anything that isn't just like you playing around on your local computer, you should use batching exporters versus simple span exporters. Simple exporters will have a lot of overhead because they have to create they have to serialize every single span every single time it closes and then send that to whatever endpoint. Batching will just, it's every 5 seconds, right? And that's configurable. The other thing you have to watch out for is making sure you define propagators. So propagators are how that context gets passed from service to service. This, again, is probably the simplest form of it. Propagation trace context is W3C trace context, and then propagation baggage is W3C trace context baggage. Once you have initialized it, then you call that in main. Always defer any of your OpenTelemetry stuff. So when you create a span, defer closing the span. When you initialize the tracing provider, defer shutting down the tracing provider. And if possible, start your tracing provider and initialize your OpenTelemetry kind of as close to the top of your app as you can, just so that and then shut it down as the last thing you do to make sure that you are not losing data. Because when you do this shutdown, when you tell the tracing provider to shut down, it will try to take anything in its buffer and get it out the door, right? So that you don't drop telemetry. What else? So in this case, yeah, you can see here in our run, this is where we're bringing in the the OTel gRPC interceptors. And a lot of times that's maybe all you need. If we go back and look at, I'll pick like a lot of the instrumentation you're seeing here is automatically generated by gRPC. So any of these, like RPC, gRPC status code, RPC method, RPC service, RPC system, like these are examples of the semantic conventions at work, right? So, and it will also automatically log interesting things that happen as part of that gRPC connection. So I can see like message received, ID, uncompressed size. I can also add other events in. In this case, we can see that we prepared, charged, shipped, da-da-da-da-da. This is sort of mimicking like what would it be like to have something on like a queue, you know. But a lot of that stuff was, again, you're getting for free with the gRPC instrumentation. You don't have to write it yourself. Swap back. Adding new things, again, pretty easy. This is what we saw in the slides where we're doing trace span from context. When you do span from context like this, you're actually getting a handle to the current span. I will say if there is no current span, then will get you a new span. So you have to kind of handle that or make sure that you're passing something in. And you can see here we're setting an attribute on the existing span. The other thing to keep in mind is if you are getting a span from context, then you should not defer closing that span because whatever put the span in the context to begin with is going to expect that it can close it, and you cannot close the span twice. That is an error. And then in your gRPC client, you need to also add in your client interceptors and server interceptors. Some other just kind of, I don't have a slide for this, just like random tips and tricks from experience doing the light step. If you, like I mentioned earlier, you usually want to use some sort of module to provide this to your end users. And there's a lot of things on here that again, they're like they're like 3 lines of code, but you can make it 1 if you have a little helper function. Things like for example, creating a span from context or like creating a child span. You can write a little wrapper that does the, defer for you. Another thing that's usually a really good idea is to use that sort of tracing module or that OpenTelemetry module to define kind of business-specific or domain-specific semantic conventions. So a great example of this is stuff like customer ID or whatever like unique identifier you have for users. Like that's something that you want to build into your module so that every other developer, they don't have to go and they don't have to add in that code. They just pull the module and they get it, right? The other good thing to do with this is obviously centralizing like your initialization and like where does the telemetry go, right? Do we send it to a collector? Do we do this, any kind of first pass of formatting, or not formatting, sorry, redaction, like removing GDPR stuff, or like person identifiable things, or da-da-da-da-da. Put that in that tracing module, or that OTel module, so that it doesn't even get out of the process. That's kind of the two biggest tips, I would say. You want to be really, really sure that you're adding in that extra metadata, though, right? Like, OTel gets you a lot out of the box, but if you want to really take it and kind of step up to the next level with it, then you need the additional bits and bobs that are domain-specific versus just what you're getting from, you know, the gRPC instrumentation, right? What else? Yeah, and then kind of the third, you know, practice tip that I've seen from how we've used it at least is it can be a real challenge to, if people are very comfortable with logging or using logging a lot, then it can be hard to kind of like prove the value of this, because people will have their logs, and in a lot of ways what you're seeing is kind of a replacement for logging. Like, conceptually it's doing the same thing that logs are doing. It's giving you sort of that, like, hey, what happened in this function, what happened in this method. But you're changing the position that it's happening at, right? Rather than having like calls at every single function, because you don't really want a trace that has every single function in your service having its own span. You usually want to align multiple functions inside one span, or a better way to think of it, you want to span for each kind of logical unit of work that your code is doing. And then for that stuff where it's like, okay, but I really do want to know what's happening in a function level, that's why you have profiling, right? And that's when you turn on pprof and you get those dumps. There are tools that are actually integrating these. So there's something called Pyroscope that is a continuous profiler for Go that actually integrates with OpenTelemetry and lets you kind of link between a span and a continuous profiling dump, which is really cool. So as more stuff like this happens, then I think that's something that you can kind of use to help people understand, like, hey, this is for service level, like transaction level visibility, and then profiles are really good for, you know, function level visibility, and you really don't need all these log statements everywhere. Like, right, you don't need to put logs everywhere. You can use profilers, you can use tracing, and then the logs should be something that are for either audit purposes or, and really, you can use traces as like audit, you know, throw into audit things, right? Like, you could take the collector, you could have it take your traces, turn them into a single log line and throw them into, you know, S3 or some logging DB, and that's where all your audit stuff lives, right? Like, it's not quite, you know, it's like, oh, traces, metrics, and logs. I really do think it's, you know, it's not one or the other, but it's definitely, you don't have to think of it as 3 pillars, right? You can think of it as 2. So I want to make sure I leave time for questions here. So let me give you a couple of things to check out. Again, the best way to learn about all this and keep in top on what's going on with OpenTelemetry is the OpenTelemetry website, opentelemetry.io. We're also on Slack, the Cloud Native Computing Foundation Slack. There are a bunch of OpenTelemetry channels. They're prefixed with OTel-. So if you go and search for OTel. You can also find OpenTelemetry on GitHub. It's open-telemetry. There's also a couple of other, yeah, I'll tweet out a link to this afterwards, so you can go and click on these links yourself. But definitely, you know, keep on top of it, and it becomes easier and easier. So that's my OpenTelemetry stuff. Now, because I have you all here and you're all lovely people, I do want to plug something real quick. I mentioned this earlier, but if you are interested in DevOps, or you have your friends that are interested in DevOps and they would like to attend the world's best virtual conference, in my humble opinion, September 14th and 15th, Deserted Island DevOps is a free DevOps conference, and it's in Animal Crossing. It's live streamed on Twitch, so you just log into Twitch and you watch it. This probably sounds really weird, but if you go to that website, there's links. It's actually very cool. And it's like 10 a.m. to 4 p.m. Eastern time, so it's kind of more in the evenings for people in Europe. But it's fun, it's entertaining. It is nothing like sitting on Zoom and listening to people talk. I can guarantee you that. So please, again, check it out.